Good afternoon, all. My name is Manpreet Chatwal. I am one of the sales executives and Markforged Solutions Manager here at A2K Technologies, and I formally welcome you all to this webinar. The agenda today for this webinar, I'm going to talk about A2K and the 0% finance campaign we're running on Markforged products for this month. Richard Elving, who is the Markforged APAC director, he was going to join us and present a quick introduction to Markforged, but Anthony Rosengreen would take over Richard's duties today, and he will, besides the customer cases that he's going to present today, he will also present the Markforged introduction to us. At the end of Anthony's session, we will take some questions. We can talk a little bit more about the 0% finance campaign we're running and go from there. So to start with, just a little bit about A2K Technologies. A2K has been a technology partner for digitization of the AEC and MFG industry for about 30 years now. We help our clients reach their full potential by delivering complete technology solutions and support services such as education, consulting, project management. As part of the RIB software, a German stock-listed construction management ERP provider, who are now 70% owned by Schneider Electric, we have a global presence, but our focus and excellent footprint in the ANZ market has been testament of our Aussie origins. We partner with numerous industry leaders, providing all sorts of technologies to our clients, and among them, standing tall is Markforged. Markforged and their additive manufacturing technology is the focus of today's webinar. For the next part of the session, I'm going to hand over to Anthony, who's going to introduce us to Markforged, who then also going to present us some case studies, introducing us to some products. But just before I do that, I want to quickly mention one of the main themes for today is to also introduce you all, if you haven't already heard about this, to the $0% interest free finance campaign we're running this month for Markforged products. The terms are pretty straightforward, which we can talk about after Anthony's session. So without further ado, I'm going to stop sharing my screen and I'm going to invite Anthony to share his screen and start his part of the presentation.
Thank you, Manpreet. Okay, so thanks for that introduction. My name is Anthony Rosengren, and I'm the Markforged Applications Engineer for Australia, New Zealand, and India. And I work for Markforged based in Melbourne with my local APAC Applications Engineering team. So as part of my job, I have the chance to visit some of the most innovative customers in Asia Pacific and to get to know them and to understand their journey towards Industry 4.0. So what I'm going to be doing today is introducing you to the company of Markforged, the industries that we play in, our products, and share a few stories, a few customer stories specific to each of our machine categories. So first, a little bit about Markforged. We were established in 2013 in Boston, which is quite old for the additive manufacturing industry. And we were founded by a team that has come from MIT, a team of engineers. We're industry leaders in enterprise adoption and enablement, so enablement of manufacturers primarily. In 2018 and 2019, we were earmarked as the second fastest growing hardware company by Deloitte. And in 2018, Forbes spruiked us as the next billion-dollar startup. We have a few strategic investors, including Microsoft, Siemens, Porsche, and Summit Partners, among others. We've raised 140 million after an 82 million Series D round in 2019. So I am personally proud to be working for a company that has the world's largest fleet of online industrial 3D printers. Markforged makes a 3D printing system or ecosystem comprised of various elements. So there's hardware, software, and materials. And these are built to be smart, robust, simple, and empowering for manufacturers. So why 3D printing and why high-strength additive manufacturing? Well, firstly, to be able to enable your business to move into Industry 4.0 and secure a competitive edge. As we all know, supply chain efficiency is an issue right now, and this sort of technology helps to enable manufacturers in this environment. The second point is to increase revenue and profits. With additive manufacturing comes a lot of simplicity in terms of labor costs. So you're able to minimize downtime, lower costs, and reduce inventory or overhead. We often talk about like a digital inventory rather than a physical inventory, which is one of the ways that cost can be saved. And finally, more productive and efficient manufacturing. So what high strength 3D printing enables is a faster line changeover by printing jigs and fixtures, for example, as well as other applications, rather than making them in the traditional labor intensive way. Greater yields and reduced lead times. So in terms of applications, I guess people are often ask me, what are the best applications for 3D printing for high strength composites? And I guess it's how long is a piece of string? One of the biggest industries that we find applications in is the automotive industry. So within this industry, we start with simple things like jigs and fixtures for bending and brazing, high strength composite work holding fixtures for alignment, machining and welding, aftermarket parts, so custom parts for very, custom vehicles, high performance carbon fiber racing parts or components for racing teams, and custom steering wheels, control grips, that sort of thing. Moving on to another industry, the aerospace industry. And what I find in Australia is that drones are a very popular application of Markforged 3D printers. And this comes because of the design freedom and the lightweight, strong components that you can make with Markforged composites. So what we see is a lot of lightweight carbon fiber drones, high strength composite work holding fixtures, composite and metal sheet metal forming tools, and high fidelity metal composite and polymer prototypes, as well as fuel injector nozzles, that sort of thing. And finally, product development applications. So while Markforged is quite useful in terms of printing jigs, fixtures, i.e. enabling the manufacturing process, it's also very useful in end-use parts, which comes into its own in product development. So what we've seen, things like electronics enclosures, high-strength mounts for cameras, motors, high-fidelity metal, composite, and polymer prototypes, and high-performance metal and composite athletic equipment. And also, let's have a look at the manufacturing industry. So this is basically Markforged's bread and butter, especially in the US. So in terms of manufacturing applications, we have a lot of case studies involving lifting tools, robot grippers, end of arm tools, cutting bits and tool coolers, composite and metal sheet forming tools, end use parts, and work holding for machining, welding, and assembly. So how do we enable such a wide variety of applications? And the answer to that is through a combination of our materials, our software, and our hardware. So what you can see here is the range on a basic level of our hardware, which I'll go through in a little bit more detail later. So we start on the left with the Mark II, which is more of a desktop machine. And on the right, you can see our metal system. And between there is the X7, which is our industrial workhorse. So what we focus on is industrial 3D printers. We're not interested in printing plastic things that break We're not interested in Yoda heads. We're interested in printing things that have high dimensional accuracy, dimensional stability, and parts that are extremely strong and light. With what you see here is this is our X7. What this has in terms of from a software and hardware perspective is a variety of elements that you can see on the left, which ensure part quality and part strength. We pay a lot of attention to software and making sure that our parts are within spec. So as part of that, we have integrated a lot of exciting AI components with our laser, which is inside our X7 machine, that ensure that the part is to spec, exactly how you've designed it, to within around about 50 microns and sometimes less. So if we move on to the materials, basically we focus on composite materials and metals. Our base material, which is a matrix, is what we call Onyx, which is a mix of nylon and chopped carbon fiber. We have a variation of Onyx, which is Onyx fire retardant. We also have nylon white, which is nylon without the chopped carbon fiber. You can then add continuous fibers in terms of Kevlar, high strength, high temperature fiberglass, and carbon fiber as a continuous fiber. And then coming soon will be electrostatic discharge. So it's basically Onyx, but it's got a high electrical conductivity. If we move on to metals, we have a variety of metals, including 17-4 stainless steel, Inconel, H13 tool steel, D2 tool steel, A2 tool steel, and copper. So what this is an example of a test that some of our graduate engineers did, where they designed a chain link that can hold 21,000 and we'll wait for it, 22,200 pounds. So that's equivalent to lifting a cement truck. So this is the sort of strength that you're getting with Markforged composite 3D printers. Okay, moving on to our metal system. Basically, the philosophy with our metal system is to be able to print pure metal parts that's safe, affordable, and easy. Many of you who are familiar with 3D printing will know that there are a lot of systems out there, but there can be issues around safety and usability of these machines. So how does this actually work? How do we make it safe? How do we make it user-friendly and reliable? So step one on the left-hand side there is that we have basically a metal powder which is bound by a wax and polymer system, and that's raveled into a spool. That is then printed using a layer-by-layer system, or FFF style. The next stage is the wash. So with the washing stage, what this does is it takes the wax out of the part in a solvent or a debinder system. Once that wax has been removed, or most of that wax has been removed, it's then sintered and in a high temperature furnace, which is inert and doesn't let any contaminants in. Once it's been sintered, you remove the part. We have a system for removing supports using a ceramic release structure. So you can simply drop the part on the ground. The support material is removed, and then you can either post-process or apply the part as an end-use part, however you wish, however your workflow is set up. So in terms of the Metal X, this is our metal printer. This is the first part of the process. How it's designed is it's similar to how Tesla operates in that they future-proof the hardware. So for example, we have a laser in here, which when it was released, wasn't used to its full capacity. But now we're increasing the software component to include AI, which is able to scan these parts as you're printing. It's able to compare different prints, so past prints to future prints, and adjust, making the printer much more accurate as time goes by. So there's a few of these software features that we're constantly pushing into these machines, which make them more reliable, more accurate, and more user-friendly. And this is what we call the digital forge. This is how we package our machines in terms of our branding. Okay, so what I'm going to do now is I'm going to share with you some customer stories. So the way that I'm going to do this is that I'm going to have a look at each of our product categories, and then I'm going to explore a customer who owns one of these products. Maybe they own a fleet of these products, and I'm going to share the story of how they've moved to Industry 4.0 from traditional methods. So I'm going to start with the smallest of our machines, and despite its size, it packs a punch in terms of availability of materials such as Kevlar, high strength, high temperature fiberglass, normal fiberglass, and carbon fiber continuous fiber filament. So the black stuff there that you see in that part is the matrix, which we call Onyx. So that's a mixture of nylon with chopped carbon fiber. And inside of that, we can inlay continuous filament. If you're interested, you can go to our website to see exactly how this works. So in terms of our first customer, we're going to start here in Victoria, where I am right now. So this company is called Additive and Robotic Manufacturing, or AARM. They started out being called Added Value Aluminium, and they distributed aluminium components to customers in Victoria. Ross Torr started Added Value Aluminium as a way of setting himself apart from the stock standard aluminium distributors of the industry. In the beginning, it was simply supplying customers with extrusions cut to length, drilling holes and punching holes. As the popularity of the service that AARM provided grew, along came challenges. The business rapidly scaled, and their customers frequently requested short lead times, leaving little to no time to fabricate custom tooling. Aluminium extrusions are not just all simple geometric shapes, as a lot of you will know. And not all customers provide you with the large production orders that allow you to invest in equipment and tooling cost effectively. Some inquiries come with short lead times, which don't allow you to acquire the fixtures needed from traditional toolmaking methods. And some customers have great ideas, but they're inhibited by the cost of tooling up. AARM found the answer with a Markforged 3D printer, the Mark II, and its material suite, which heavily features continuous fiber, as I mentioned before, chopped carbon fiber and nylon, as well as continuous fiberglass, which they typically use in their workshop. ABS plastic, which they were previously using, was simply not strong enough nor resistant to the cutting fluid around their machines. But this wasn't a problem with Onyx. So since the introduction of Markforged 3D parts into their production floor, AARM have been able to produce strong and reliable parts. Build failures are extremely rare, and they're able to print large parts or many different parts at one time over one continuous build without worrying. Incorporating Markforged additive manufacturing has slashed costs associated with retooling, as well as enabling automation and the repurposing of old machines. The team have now moved from PLA or ABS to Markforged to make industrial grade parts. This has allowed the business to make a complete working production units, such as their pneumatic portable clamping system. And I'm going to discuss this part in a bit of detail in this slide here. So what this is a part designed by AARM, and it's a custom pneumatic portable clamping system that was completely 3D printed, except for the aluminium extrusion base and the pneumatic air cylinder. It was easy to set up on the drill press, on the milling machines, and the automatic tapping machines, and copy routers as needed. They can print the basic pneumatic clamping system parts at any time with no need to set up tooling on the production floor. All they need to do is cut a bit of extrusion, buy an air cylinder, print the parts, and we have another effective clamping system unit ready to go. Another big plus is that if there is a machine or operator mishap, the damage isn't too costly. All you have to do is print a new fixture overnight. There is no need for costly repairs or loss of production, and there's no need for machine downtime. So moving on to the X7. So this is a truly industrial machine that delivers all of Markforged matrix and continuous fibre materials in a much bigger build volume than the Mark II and faster print speed as well. This also features a raft of different software features which aren't available in what we call the desktop series. So who's using the X7? Well, here's an example. SureGrip Hand Controls is a leading manufacturer of aids for disabled drivers. They're a veteran of additive manufacturing and have worked with 3D printers since 2012. As they began expanding into international markets, they realized that in order to compete, they needed a next generation solution which would give them part quality and part durability to rival molded components. SureGrip Hand Controls is a leader in the disabled driving aids market in Canada and the US. The president and founder, Keith Howell, became a quadriplegic in his early teens, but he still carried a strong desire to drive a car and to be independent. So after trying many different types of hand controls, only to find that the manufacturer of his preferred style was no longer in business, Howell founded SureGrip in 1986 to bring the push rock style of hand control to the market. Since then, the company has become a highly innovative manufacturer with a mission to bring independence and mobility to users around the world. So in terms of SureGrip's journey, they actually started with a ABS machine. They're an early adopter of 3D printing, but what they found was that this was quite effective in producing a usable part, but ABS has a particular sheen to it, and you could see the layer line, so you could see that it was obviously 3D printed. And this was fine for the local market because it did solve the problem, and it did what it needed to do. But what they needed to do, they wanted to expand. They wanted to expand into international markets like Australia, New Zealand, and South Korea. And they realized that in order to compete in markets where they weren't well known, they needed products which didn't lean on reputation and could speak for themselves. They couldn't achieve this with their other machine, so they needed a solution that would give them the visual quality and the appeal to compete. So the part that you see here is the body of the RF Mini, a control device that helps drivers operate several secondary functions of the car, like the horn and the windshield wipers. It centralizes multiple controls into one device, working in tandem with a receiver integrated into the vehicle. It originated as a sketch meant for a single customer, but 3D printing has made it practical to produce a custom solution which performs so well that it became successful in its own right. The Markforged printed version is made of Onyx and is assembled directly off the printer with no finishing required. While end-use production of the RF mini body is already making a big impact at SureGrip, the SureGrip team recognizes that the X7 has equally great potential down the road, with growing market demands for customization. Cody and the SureGrip team are looking forward to taking on more complex, high-value jobs which require custom tooling and investigating automation solutions. So finally, we move to the Metal X, a safe and reliable additive manufacturing solution which uses a print, wash, and sinter workflow. With this unit, you can print a wide range of metal materials, including copper, stainless steel, tool steel, and Inconel. And what you end up with are pure metals ready for machining. So who's using the X7? Well, apologies, who's using the Metal X? Well, one company which is using the Metal X is Sandia National Labs. So Sandia National Labs is a science lab funded through the Department of Energy in the US. Among a wide range of other projects, they're chartered with contributing to a body of research to improve the efficiency of internal combustion engines. To support this mission, the team produces physical simulations of different diesel fuel flow scenarios. As the team at Sandia pushes the boundaries of design, they run up against physical manufacturing constraints. So in order to produce the unique internal geometries that result in optimal flow, they used to rely on third parties for a combination of laser sintering and CNC machining. So as you can imagine, when you're designing, this source of geometry, it can be extremely complex. And to get those internal channels is basically impossible with traditional CNC machining techniques. So while the resulting part that they ended up with from outsourcing these geometries were functional, they took weeks or months to get the final part, and the part may cost tens of thousands of dollars. The Markforged platform now helps Sandia produce the complex geometry they need to develop next generation engines. It also helps Sandia avoid expensive and time-consuming third-party vendors. The team has drastically simplified their workflow, which is now design, print, and then post-process with an internal CNC machine. While Sandia has previously looked into laser sintering options, Markforged was the first solution that could print metal in-house while conforming to their environment, health, and safety requirements. This new capacity means lower lead times and more high-quality iterations, a huge benefit for experiments that affect the many verticals that depend on internal combustion engines. So let's have a look at one of their applications. This is a model of a diesel spray model that was printed in 17-4 stainless steel on the Metal X. The nozzle is characteristic of the Type D nozzle configuration, which helps Sandia contribute to a body of research data. The internal geometry is highly intricate, requiring non-traditional techniques to achieve internal flow lines. The Metal X is able to print this structure inclusive of the internal complex geometry, which previously required highly specialized and significantly more expensive equipment. After printing, critical surfaces and mating features were then fine-tuned using a CNC mill. There are immediate performance impacts that Sandia looks to quantify in testing, including the lightweight lattice facilitated through the printing process, along with the layer lines on an unprocessed surface. So these layer lines actually facilitate a more efficient turbulent boundary layer for those engineers listening to this. The process this workflow has since led scientists and engineers at Sandia to investigate the feasibility of printing additional high-impact components that utilize some of the other specialty materials available on the Metal X. And these include high-temperature valves and nozzles in Inconel, among with other critical fixturing components for imaging. So a nice thing about this process is that Markforged have allowed Sandia's engineers to be more innovative by encouraging them to fail fast and iterate fast. These are just a handful of the stories on our new microsite, 100 Ways to Reinvent Manufacturing. Each of these stories shows a unique insight into how high-strength additive manufacturing can be used can add a huge amount of value to all sorts of businesses and customers. So with that, I'd like to hand back to Manpreet from A2K.
Great. Thanks for that, Anthony. Much appreciated, very informative. I think we should now jump straight into Q&A. I think it's probably perfect timing for have some Q&A time. I've got a few questions that during the presentation people have been asking. If I can address them to you, Anthony, one by one. One of the questions I have here is, can you please tell me what's your maximum print volume for your Onyx machines?
So the maximum print volume for Onyx with our X7 is 330 by 270 by 200 millimeters. So that's the build volume.
Okay, great. I think there's another question here, which is about the material. So someone's asking, how does Onyx with carbon fiber strand compare with, say, 6061 aluminium?
So that's they're quite comparable in that they can generally be, you can replace one with the other. So typically, if I'm doing a walk through a factory floor, if I see something made from aluminium, it typically can be redesigned for a composite, a composite process and printed. So if you print with Onyx only, you're going to get a bit of bend. But if you then add continuous fiber filament, then you can achieve the stiffness, the same stiffness of 6061 aluminium. So it just depends on how you place that fiber.
Okay, great. In case people need follow-ups to their questions, please feel free to send me an email. If we need to set up a separate time with Anthony, we can do that. There's another question here. Someone's asking, what is the dimensional accuracy of X7 as in repeatability?
So in terms of dimensional accuracy and repeatability, when with 3D printing, generally this is going to be geometry dependent. So it's also dependent on the X versus the Y and the Z directions. But in general, the accuracy and repeatability is around about 50 microns or better with the X7. But it depends. If you've got a very large part, it might be a bit more than that. If you've got a smaller part, it might be a bit less. So that's what the in-process inspection helps to define.
Okay, great. Another question is about materials again. Does Markforged has any plans to release other plastics, for example, ABS and PET for your printers?
So we never say never, but we depend on feedback from industry. So far our feedback is that people want extremely high strength parts that are also light. So we're not going to release something that other 3D printing manufacturers already do blindly, and typically we'll tweak it to ensure that the people printing with our parts are getting a part that is extremely high quality. So yeah, the short answer is maybe. It just depends on on what the demand out there what the demand is in the market. For example, as I mentioned, we're releasing an electrostatic discharge material, which has a higher electrical conductivity, and that's what our customers have told us that they want. When our customers ask us that they want something else with different properties, we'll listen, and if there is enough demand, then we generally work on that material.
Okay, great. I've got another question here. Can you please repeat the maximum dimensions printable with X7? So I think build volume question again here.
No worries. So just get that again. So if you need the build volume dimensions, this is all freely available on the website if you forget those. So I'll just quickly go to them. So if we can just, oh yeah, here we go, sorry. So it's 330 by 270 by 200 millimeters. So that's X, Y, and Z.
Okay, cool. And I think there was another question here. What's the purpose of the high electricity filament?
So Onyx ESD, or electrostatic discharge, basically we provide a material that has certain material properties, and what it does is that it enables electricity to flow more freely, as Onyx by itself is an insulator. So generally the purpose will be for electronic components for safety, to make sure that electricity can flow through electrical housings, for example, easily. But there's going to be a whole raft of other purposes. For example, if you can for powder coating, for example, if you can put a current, through a 3D printed part, then it makes it much easier to powder coat. So there's going to be a whole range of applications for electrostatic discharge Onyx.
Right. I have another question here. I work in defense. Is there a completely offline option available for your printers?
Yes. So one of the nice things about Markforged is that we are the only additive manufacturing company to have a security page on our website, which is only dedicated to security. The short answer is that there is an offline version of our slicing program, which can be bought for customers who want zero access to the internet. But the other point is that if security is an issue, we do have a high level of certification, for our cloud-based software. And you can, if you want to call A2K, you can be put through to me to discuss that in more detail. So each customer will have different security requirements, and we can cater to that.
That's great. And I think it's worth pointing out that defense is probably one of the most important and biggest clients for this technology. That probably is, again, reinforces the fact that they are comfortable with the security implications that may that this technology brings, especially with the environments, the restriction on environments that they have to work in.
Exactly.
Right. I think there should be. What's the purpose? We've done that. Are the Markforged filaments UV stabilized, and will they bring out some more fire retardant filaments?
So we have done a fair bit of study on UV stability, especially under the Australian sun. And what we have found is that Australian UV, which is particularly harsh, penetrates 1 millimeter into the Onyx filament. So as long as, if you want to put things outside and leave them outside for years, that's totally fine. And we have parts, under the Australian sun right now performing their function. For example, battery housings. But what we recommend is adding 1 millimeter of thickness in the slicing software to help protect, against UV. There's also a range of paints and surface coatings that you can use to add further protection. In terms of fire retardant, we don't have a plan to release another fire retardant material, but the fire retardant material that we do have is certified, for applications such as aerospace, where that is an extremely important, factor to have.
Absolutely. Great. Thank you. I don't see any other questions, but I think one important bit that I want to reiterate here is that we do have a perfectly good campaign running this month, which is $0 deposit, 0% finance for anyone who's interested in procuring these wonderful products from Markforged. So if you need to know a bit more about what the terms are fairly straightforward. So you don't pay a cent more than the cost of the actual printer, and you have 24 and 36-month terms available. If you need to know a bit more about that, please give us a call. The email that you would have received, or reply to that, or give me a call on my mobile number, which is 0407-671-076. Any other comments, Anthony, you would like to make today?
No, nothing particularly from me. If you have questions, please feel free to reach out to A2K. And if the questions get a little bit hairy, I'm more than happy to engage and understand your application to see, what material would be best fit.
Great. I think I don't have any other questions from anyone. But if, as I said, you have any questions, just give me a call. And we will be more than happy to help. We will end our session for today, and we hope to speak to you all soon. My thank you very much to Anthony and our marketing team who have put this together and all the guys who've attended today. Thank you very much for your time.
Thanks, everyone. Thanks, Manpreet.
Cheers. Thank you. Bye-bye.